All right, we are talking about equivalent fractions. Okay, so the standard for identifying and generating equivalent fractions is MA.4.FR.1.3. So the standard says that we want to identify and generate equivalent fractions, including fractions greater than 1. So that just means fractions whose value is more than one whole. And then we want to describe how the numerator and the denominator are affected when equivalent fractions are created. So first things first, we got to make sure we know what the parts of the fraction are. The numerator are the number of parts in the whole, and the denominator is the number of parts the whole is divided into. So if I have a circle and I divide it into 3 equal parts, that's representative of my denominator. But if I then shade 2 of those equal parts, that's my numerator. Now, 2 or more numbers that have the same value are equivalent, and 2 or more fractions that name the same part of a whole are equivalent fractions. So in order to generate an equivalent fraction, not just identify an equivalent fraction, we need to remember that something that's equivalent is going to cover the same area in the whole. So I'm going to draw this rectangle, and on top, I'm going to divide the rectangle into 5 equal parts, or as close to equal as I can get it, right? I've got 3 parts shaded. If I turn this bottom rectangle into 10 equal parts to match the top, and I shade 6 parts, we can see that like the same area is shaded. So top rectangle and bottom rectangle with the 10 equal parts cover the same area covered. That's a visual representation, but we don't typically draw models for our tests. It's just good to understand what it looks like in our mind's eye. If I want to generate an equivalent fraction, there's 2 ways I can do this. I can multiply the numerator and denominator by the same number. So going back to my example, my top fraction is 3/5. My bottom fraction has 10 parts in the whole, but I never mentioned how many parts were in the numerator. That's what we're going to figure out now. So in order to get to 10, I have to multiply 5 by a number, and that number is 2. So 5 times 2 equals 10. In order to make sure my numerator has the same value in a fraction that has 10 equal parts as it has in a fraction that has 5 equal parts, I've got to multiply it by the same number that I multiplied my denominator by. So my numerator and denominator are both being multiplied by 2. My numerator, 3 times 2 equals 6. The equivalent to 3/5 is 6/10. Let's try that again. Let's say I've got 1/4. Let me draw a square here. I shade that area. I draw a similar square to the side, picking a different color. I've got the 4 equal parts, but I'm going to divide each of those equal parts evenly. Now I've got 8 equal parts. If I shade to show the same area that's covered, I've got 2 equal parts shaded. Now, if I want to prove this mathematically, I'm going to make sure I multiply my denominator and my numerator by the same number. 4 times blank is 8. 4 times 2 is 8. 1 times blank is 2. 1 times 2 is 2. Okay? So now we want to talk about the other way that we could generate an equivalent fraction. The same way that I would multiply my top and bottom number by the same number to generate an equivalent fraction, I can also, where possible, divide the top and bottom number by the same number. So in this case, both of these are even numbers. I'm gonna divide them by 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4. And that's how we can both generate equivalent fractions and identify them. Thank you so much for watching. Hey, I want to encourage you to keep practicing. You can find additional resources to help you out, like worksheets and games, on my Teachers Pay Teachers store. Also, you can help me out by letting me know if you found this video helpful. Just send me a like if it was helpful, and send me a comment if you want to let me know what skills you'd like to see me cover next, and subscribe so you can find out the next time I post. Bye!